Electronic navigation represents the most striking change in the modern history of sailing. As recent as the turn of the century, navigation primarily relied on paper charts. Planning, executing and monitoring a voyage consumed most of the time and attention of a crew. However, the introduction of modern digital navigational tools automated much of the work and changed the nature of transoceanic travel. As a result, Ecdis, an electronic chart display and information system, is a geographic information system used for nautical navigation that complies with International Maritime Organization regulations as an alternative to paper nautical charts. IMO refers to similar systems. Ecdis can improve the safety of navigation. For example, it has significantly improved the accuracy and reliability of navigation charts, corrections and updates, such as wreck and cable positions, used to be added manually on paper charts. There are two types of electronic charts that an Ecdis can display. Electronic navigational charts, ENCs, otherwise known as vector charts. Raster navigational charts, RNCs, a dumb chart. What are the elements of Ecdis? The Electronic Chart Display and Information Systems, Ecdis, is an advanced computer system that integrates electronic navigational charts, electronic coastal charts, electronic sailing directions, electronic tidal current tables, other information. The IMO performance standards permit national maritime safety administrations to consider Ecdis as the legal equivalent to the charts required by Regulation V/20 of the 1974 SALAS Convention. Electronic navigational charts, ENC, also known as vector charts, are data sets to support all types of nautical navigation. Originally, large commercial vessels adopted them for the sake of SALAS compliance, efficiency, and safety benefits. Electronic coastal charts are used to show uninterrupted wide-ranging coverage with adequate inshore detail to make landfall easy. Sailing directions known as pilots are written directions that describe the routes to be taken by boats and ships during coastal navigation and port approaches. Admiralty Sailing Directions, 76 volumes. Tide tables or charts list the daily high and low tides for all the tide stations in a given area for an entire year. Current tables list the maximum flood and ebb and the times of high and low slack current. What is an electronic navigational chart, ENC? Electronic navigational charts are one of the two key elements of electronic navigation. An Ecdis functions as the hardware, while an ENC contains the dataset of relevant information for a voyage. Together, these two components create a powerful digital navigation solution. However, they bring much more to the table than eliminating paper waste and storage via basic digitization. Using electronic navigational charts together with Ecdis provides a crew with an array of advantages in planning, monitoring, and executing voyages. Electronic navigational charts, ENC, also known as vector charts, are data sets to support all types of nautical navigation. Originally, large commercial vessels adopted them for the sake of SALAS compliance, efficiency, and safety benefits. In the modern nautical landscape, smaller ships and recreational sailors also make use of ENCs in Electronic Chart System, ECS, programs. Electronic navigational charts are the main type of charts that an Ecdis relies on. In their complementary role to Ecdis hardware, an ENC provides a diverse array of information and automation features. These include, but are not limited to, routes, maritime limits, aids to navigation, depths, nature of the seabed, elevations, configuration and characteristics of the coast. In 2019, NOAA announced its sunsetting of raster nautical charts in the Federal Register. The raster sunset program will gradually end production and maintenance of NOAA traditional paper and raster nautical chart products. Beginning in 2021, NOAA will start canceling its traditional nautical charts. The process is expected to be completed by January 2025. ENCs are smart charts, which means the user can click on different features, such as a light or buoy, to retrieve additional information not available in paper or raster charts. For example, a wharf appears only as an image on an RNC, but an ENC can identify it as a wharf and attach attributes to it such as height, length, age, ownership, number of berths, etc. This additional data, which is contained directly within the ENC, might otherwise only be available by consulting the relevant sailing directions publication. ENCs used on an electronic chart display and information system, Ecdis, and integrated with other data such as GPS position, radar, planned routes, heading, speed, and draft, assist mariners and alert them to sailing hazards, warnings, and dangerous situations. ENCs are powerful and flexible navigational tools that provide users with more control over the display of the chart. What is raster charts? You may not be able to get ENCs covering the whole voyage. In such cases, you can resort to raster charts. These are much more simple digital tools. They consist of scanned version paper charts you can store electronically. Conversely, raster charts don't have any extra functionality. You can't expand or remove certain information elements, and there's no built-in alarms or depth features. Using a raster chart more or less resembles loading and observing an image on an electronic device. In these charts, you can constantly visualize all text and chart data. Zooming in or out will equally affect every part of the chart. Similarly, if you rotate the chart, you will rotate the text together with the image. The 5 mandatory alarms, as per Ecdis performance standards, are: crossing safety contour, deviation from route, positioning system failure, approach to critical point, different geodetic datum. What is the greatest single danger from Ecdis? System lag. Modern Ecdis software can have a lot of data to display. And with various equipment interfaced with the Ecdis, the system can slow down very easily, leading to system lag. What is the main limitation in use of Ecdis? It is only an aid to navigation and never replaces the human quotient, which brings in the skill and expertise with experience that an Ecdis can never provide. What error may occur in the Ecdis if hydrographic or chart survey data is inaccurate? It will disrupt the normal operation of the Ecdis being used, the route plan used cannot be displayed, and chart data can only be deduced. Which chart display options will produce a most uncluttered screen when using the night palette? Which are the major errors involved in Ecdis? Source error: an electronic chart can be as good as the original data it was derived from. Position shift: there will be position shift shown between GPS and actual position on the chart if the GPS and the chart are using different datums. What are the colors of navigable area on Ecdis display? By just feeding in the safety contour setting, the Ecdis ENC display is subdivided into blue, no-go, and zones. Now let us see how the Ecdis screen will look like with all these settings. So let us say vessel's draft is 9 meters and vessel require 14 meters depth to comply with company's UKC policy. So, we have these settings. Shallow contour, 9 meters. Safety depth, 14 meters. Safety contour, 15 meters.
As with paper charts, it is vital that the navigator choose the correct chart scale for the task at hand. Navigating coastal waters with Ecdis set to scale for oceanic transit can be extremely dangerous, as some navigational hazards may not be visible. The watch vector is perhaps the most important Ecdis setting. The watch vector is also known as the anti-grounding cone or look-ahead setting. and is based upon the stopping distance and turning radius of the vessel. The watch vector defines the area in which Ecdis will alarm should the vessel approach a navigational hazard. Without this setting, the Ecdis will provide no advance warning. Additionally, watchkeepers should verify the safety contour and spot depth settings on the Ecdis. The broadest depth setting is the safety contour depth, which provides a visible boundary between safe and unsafe water. The safety contour depth is set by the navigator to reflect the vessel's safety draft, which is commonly calculated as the vessel draft plus dynamic squat plus the safety margin. Ecdis displays soundings as well as depth contours. Safe soundings are indicated by the safety depth. In most situations, the safety depth and safety contour depth will be the same. Safety depth should never be less than the safety contour. Navigators may choose to display depth contours in 2 or 4 colors. It's most important that navigators verify their understanding of the chart display, as settings like night mode may lead to confusion. Additional depth information can be displayed by the shallow and deep contour settings. Most importantly, raster charts cannot be read by the Ecdis. Vector data is necessary for navigational alarms. If functioning in raster chart display system, or RCDS mode, the terminal will not warn of navigational hazards.